Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at S-block elements. S-block elements are elements in which their last electron, that is, their differentiating electron, enters an S orbital. Elements of group 1 as well as elements of group 2 are S-block elements. Group 1 elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Group 2 elements are beryllium, magnesium, calcium, strontium, barium, and radium. S-block elements are very reactive. Group 1 elements are also known as alkali metals, while group 2 elements are also known as alkali metals. So let us look at the general characteristics of S-block elements and offer explanations where necessary. The first one is that they are soft metals with low melting and boiling points. The second one, they have low values of ionization energy, meaning that the amount of energy required to remove an electron from atoms of these elements is small. The third one is that they are very reactive and form ionic compounds. The reactive nature of S-block elements is the reason why they are not found freely in nature. They always exist in a combined state. The fourth one, they show a fixed valence which depends on their valence electrons. Elements of group 1 are monovalent, which means that they have a valency of 1, and this is because they have 1 electron in their outermost electron shell. Elements of group 2 are divalent, that is, they have a valency of 2. This is because they have 2 electrons in the outermost electron shells. S-block elements act as strong reducing agent. This is because they have very negative values or highly negative values of reduction potential. The sixth one is that they impart a characteristic color to the flame, with the exception of beryllium and magnesium. Before we look at the exceptions, let us look at what happens when a metal is subjected to the flame test. When a metal is subjected to the flame test, what happens is that the electrons absorb heat energy from the flame and move from a lower energy level to a higher energy level. The movement of electrons from a lower energy level to a higher energy level is called excitation. In the excited state, the electrons are not stable. So they quickly move from the high energy level back to the lower energy level. And in the process of doing this, they emit light in the form of photons. Beryllium and magnesium do not impart a characteristic color to the flame test for 2 reasons. The first one is due to the fact that they have high ionization energies. In other words, the energy that is required to excite electrons, that is to move the electrons from the lower energy level to the higher energy level, is high. The second reason is that the energy transitions of beryllium and magnesium are in the ultraviolet wavelength, that is, the UV wavelength. And the ultraviolet wavelength is not visible to the human eyes. The next point is that their compounds are predominantly ionic, except those of lithium and beryllium. The compounds of lithium and and beryllium are usually covalent. And the reasons for this are: 1. Lithium ion and beryllium ion have small sizes. So this means that the small size of the cations is one of the reasons why they form covalent compounds. Another reason is because the lithium ion and beryllium ion are highly polarizing. What this means, when you say that they're highly polarizing, is that they distort the electron cloud of anions such as fluoride ion, chloride ion, as well as oxygen ion. They don't only distort the electron cloud of these anions, they pull the electrons towards themselves, and this favors sharing of electrons, which is what covalent bonding is based on. The third reason is their low values of electropositivity. Lithium and beryllium are not as electropositive as other members of their group. They have no electropositive values when you compare them to other members of their group. So because of that, they tend to favor sharing of electrons than completely losing electrons. The next point is that, with the exception of beryllium and magnesium, they decompose water and readily liberate oxygen. Beryllium and magnesium do not decompose water and also do not readily liberate oxygen. And the reasons why they don't are as follows. The first reason is because of their high values of ionization energy. Because due to the high values of ionization energy that they have, it becomes difficult to get the electrons that are supposed to react with water and decompose it. The second reason why they don't decompose water and readily liberate oxygen is because on exposure to air, beryllium and magnesium form oxides, beryllium oxide and magnesium oxide respectively. Now, these oxides offer or bring about a protective coating on the surface of the beryllium and magnesium metals. As a result of this, water molecules are not even able to get to the underlying beryllium atom or the underlying magnesium atom, not to talk of even reacting with them in the first place. The last one is that they displace hydrogen from acids and form corresponding salts. This is as a result of their highly reactive nature. I want to believe that this explanation of the general characteristics of export elements is clear. Thank you for viewing, and see you in the next one.